All right, let's dive into the fascinating world of lines. We've got our notes and study guide ready to go on linear relationships. And, you know, this isn't just some boring old dusty equation stuff. We're going to be talking about stuff like stock market trends and rocket launches.
It really is amazing how something as simple as a straight line can contain so much information.
Yeah, exactly. And by the end of this, you'll be the one explaining those stock market trends. You'll be explaining what's going on in the news with graphs and charts. Yeah, no problem.
Right.
So let's, the notes mention these things like recursive routines, rate of change, and those things might seem intimidating, but I think if we break them down, it won't be that bad.
Yeah, definitely.
What do you think?
A recursive routine, that sounds scary, but imagine just building a tower of blocks. You add one block, then another, then another. You're basically creating a recursive routine where the height of your tower depends on how many blocks you've already stacked.
Okay, so each step's connected to the one before it. I
Yeah.
get it. All right, now what about this rate of change thing? That sounds like physics to me.
I know it might sound complicated, but just think about going on a road trip. You're driving along and you want to know how fast you're going. That's your rate of change, how much your distance is changing over a certain amount of time.
Oh, so if I'm speeding, that means my rate of change is like way higher.
Exactly.
You got it.
Okay, cool. So now let's think about where our line, begins, like its journey, the starting value.
Yeah, so think of it like home base on a map, like the value of y when x is 0.
Hmm.
Or on a graph, it's the point where the line crosses the y-axis.
So if I was like tracking my progress in a video game, my starting value would be my level when I first start playing.
Exactly.
Oh, okay, cool.
Now, you've probably been staring at ymx plus b in your
Yeah, I
notes.
was going to say, what's with
Yep.
all the letters?
It might seem a little confusing at first,
Yeah.
but that's the slope-intercept form.
Okay.
And it really helps unlock everything about a line. So can you, tell me what those letters actually mean?
Yeah, so M represents the slope, which is the steepness of the line. Think about skiing. A steeper slope means you're going to go faster.
Yeah. So a bigger M means a more dramatic, like rise or fall.
Right, exactly.
Okay, what about B?
B is the y-intercept, that home base we talked about earlier. It tells us where the line crosses the y-axis, our starting point.
Okay, so M is our speed and B is our starting line. Okay, I'm starting to see how this all fits together now. But what if we don't, actually have the equation? What if all we have is like 2 points on a line? Can we still figure out the line's secrets?
We can, absolutely. We can use those 2 points to figure out the slope, or the m, in our equation. And for that, we have the slope formula.
Yeah, okay, bring on the formula.
All right, so it's all about rise over run. How much the line goes up or down, that's the rise, compared to how much it moves horizontally, the run.
So if my line goes up 2 spaces, for every 1 space it moves to the right, my slope would be 2 over 1, or just 2.
Yeah, you got it.
Okay, so it's kind of like a staircase then, how many steps you go up versus how many steps you take forward.
Exactly.
This is making a lot more sense now. All right.
Yeah.
I'm liking this slope formula thing. Now, what about these parallel and perpendicular lines? What's so special about them?
Well, imagine you have two parallel lines, kind of like train tracks running side by side. They'll never cross, right? And that's because they have the same slope, they have the same steepness, they always maintain that same distance from each other.
So parallel lines are like two runners on a track. They're both running at the same speed, but they're in different lanes.
Exactly.
Okay, and then what about perpendicular lines?
So think about two streets intersecting at a perfect right angle. Those are perpendicular lines, and their slopes have a really unique relationship. They are negative reciprocals of each other.
Wait, hold on. Negative reciprocals. What does that even mean?
Okay, so let's say you have one line that has a slope of 2. Its negative reciprocal would be negative 1/2. So you just flip the fraction and change the sign. And this special relationship makes sure that the lines will always meet at a 90-degree angle.
Gotcha. Okay. I'm starting to see the pattern here. It's pretty amazing how these, seemingly simple concepts can actually tell us so much about the relationship between lines.
It is, yeah. Yeah, it's pretty cool. And there are a couple more line types that we should talk about. Horizontal and vertical lines, those always kind of trip me up. They seem so simple, but I always mess them up.
Yeah, me too.
Well, for a horizontal line, think of like a horizon. It's flat. It doesn't really change. It stays at the same level. The slope is 0 because it's not rising or falling. No matter how far you travel along the x-axis, the I value always stays the same.
So it's kind of like driving on a flat road, like no hills or anything.
Exactly.
Okay, that makes sense. What about a vertical line?
So imagine the edge of a building is just going straight up, right?
Yeah.
That's a vertical line. And its slope is undefined because it's only rising. It doesn't have any horizontal run.
Okay, so it's like, a rocket taking off straight up in the air.
Exactly.
Okay, cool. So remember how we talked about the slope-intercept form of a linear equation?
Yeah.
Well, there's another form that we should talk about too, the standard form. It looks a little different. It's ax plus by b equals c.
Yes, the standard form. It may seem a little less intuitive at first glance,
Yeah.
but it has its own uses.
Okay, well, what kind of uses?
Well, it can actually make it really easy to find the x and y-intercepts of a line. You just set x to 0 to find the y-intercept, and then you set y to 0 to find the x-intercept.
Okay.
So, bam, you've got your 2 points, and you can draw your line.
So it's kind of like a shortcut.
Exactly, a shortcut to finding those points.
Okay, that's pretty handy. Any other, cool things about the standard form?
Well, it's also really helpful when you are working with something called systems of equations. That's where you are trying to find where two or more lines cross each other. You might see that later on in math or even in real-world things like economics and engineering.
Wow, this is starting to seem, less about lines on a graph and more about really complicated stuff.
It is. It's all connected.
It's pretty cool.
Right.
But why would we need two different forms of a linear equation?
Right.
It seems like that slope-intercept form is way easier to, picture in your head.
Right, yeah. The slope-intercept form, that's really great for visualizing a line, but sometimes the standard form is just better for doing certain math, especially when you are dealing with lots of different equations. It's like having different languages to express the same idea.
So it's all about using the right tool for the job, I guess.
Exactly.
This is really making me think about all the ways that, we see linear relationships every day, even if we don't realize it.
Oh, yeah. They're everywhere.
Like what?
Well, think about the number of hours that you work and the amount of money you make. That's a linear relationship. The more hours you work, the more money you make.
Oh, yeah, and the slope of that line would be like your hourly rate.
Yeah.
And the intercept would be like any bonuses you get, regardless how many hours you work.
Exactly right. And you can use linear equations to understand things like population growth, how information spreads online, and even the relationship between supply and demand.
Oh, wow. Okay, this is really cool. I never realized how much this all connects together.
Yeah, it's amazing.
All right, well, before we, finish up with lines, I want to just make sure we have all of the key takeaways for our listener today.
That was good.
So we started off by, breaking down those kind of intimidating terms, the recursive routines, and the rate of change. And, we talked about how recursive routines are all about, building on the previous step of stacking those blocks. And then rate of change is just, how much one thing changes compared to another, the speed of a car. We also looked at the two main forms of linear equations. There's the slope-intercept form, which is y equals mx plus b, and that gives us a good picture of a line's slope and its starting point. Then there's the standard form, which is ax plus by equals c, and that's good for finding intercepts and is helpful for more, advanced math stuff.
Right. And then we dove into those parallel and perpendicular lines.
Oh, yeah.
And we talk about how they have special relationships with their slopes. The parallel lines, they maintain a constant distance. They have the same slope, like those runners on a track. And then the perpendicular lines, they intersect at a right angle, and their slopes are negative reciprocals.
We also talked about those horizontal and vertical lines.
Yeah, and we cleared up, how horizontal lines have a slope of 0 because they don't rise or fall at all. And then vertical lines, their slope is undefined because they're only rising and there's no horizontal movement there.
And then I think most importantly, we talked about how all of this, actually has a ton of uses in the real world.
Yeah, in tons of different fields.
Yeah, it's not just about lines on a graph.
It's about understanding data, understanding trends, understanding how things change over time.
Well, before we, move on from the world of lines, I want to leave you with a final thought. We've talked about how you can use linear equations to, model and predict things.
Yeah.
But what happens when those trends, they don't follow a straight line? What about when the relationship between things isn't a straight line, but it's more complex, like a curve or something?
Yeah, well, that's when things get even more interesting. That's where we get into nonlinear relationships and exponential growth and all kinds of new math come into play.
So even though we're wrapping up our deep dive on lines here today, there's still so much more to learn. It's really like opening up a whole new door to the world.
Yeah, absolutely. And even though we've, covered so much today, It's just the tip of the iceberg when it comes to linear relationships.
Yeah, there's always more to find out, right?
Oh, for sure. So, keep an eye out for straight lines in your everyday life. You'll see them in news articles and financial reports, even scientific data. And try and apply what we've learned today. You might be surprised by how much sense it all makes now.
Yeah. And if you ever come across a graph that's not a straight line, don't worry. That just means that there's a whole new adventure waiting for you out there.
Exactly. That's the world of nonlinear relationships.
So keep on exploring, keep asking questions, and stay curious.
Yeah, I love that. Well, it's been awesome diving into this stuff with you.
Yeah, same here. We hope you enjoyed this deep dive into linear relationships. Remember, you've got the power to understand this stuff now. So go out there and make sense of the world one line at a time.